Hey everybody, welcome to the Unit 3 review. We're covering here absolute value functions and inequalities, transformations of the absolute value functions, solving absolute value functions, and solving absolute value inequalities. So I'm going to do everything on the we do side, you take care of everything on the you do side. So that being said, let's begin. Number 1, given the graph, identify the following information. Identify the vertex, axis or line of symmetry is the vertex of max or min, the x-intercept or x-intercepts, the y-intercept, and then the domain and the range. So where's my vertex at? My vertex is this point right here. What's the coordinates of that point? It looks like it's 1, 2, 3 to the left, so -3, and then down 2. -2. And remember, if you have the function, I might as well just bring this up since it's on the test anyway. This +3 made it go left 3. This -2 made it go down 2. Left 3, down 2. The vertex is now at -3, comma, -2. So that axis or line of symmetry is the imaginary line that cuts the graph in half, and it always will run through the vertex. So you're just using the x value of the vertex. What was the x value of the vertex? -3. So you have to say x equals, because any vertical line equation is x equals. So x equals -3. Is the vertex a max or a minimum point? This is the lowest point because the graph is opening up, making a V. So everything it touches above it is above it. Yeah, I don't know. So say it's the minimum point. Now, the next thing to identify is your x-intercepts. So we have two of them. They're right here and here. So what are the coordinates of those points? It looks like this one's at -1, 0. And then this one's at -1, 2, 3, 4, 5. And -5, 0. So that's all there is to say about that. Just list them. -1, 0, and -5, 0. Okay. What is the y-intercept? The y-intercept is where it touches the y-axis. And so it looks like it touches the y-axis right here. Where is that at? That's at 0, 1, because it went up 1 on the y-axis. It didn't move anywhere on the x-axis. So 0, 1. Remember, x-intercepts, they have 0 for the y, and then y-intercepts, they have 0 for the x. You have a number for the x for x-intercepts, and you have a number for the y-intercept. And then the domain and range. Well, the domain on any absolute value function is all real numbers because it can move left and right. It can move left and it can move right freely. It's unobstructed. So you just say all real numbers. And remember, there's two different ways we write that. We either say -infinity to +infinity, and they're both in parentheses. Or you can use the all real numbers symbol or spell out the word all real numbers. The words. The range, however, that is not all real numbers. The range, it's going from here and up. So what is the lowest point? Remember it went down 2. So you know how you use the x value for the line of symmetry? Use the y value for the range. So it went down 2, and then it's going up above that. So from -2 and above, so that means you can put a bracket at -2 and go up to +infinity. Or you can write it as y is greater than or equal to -2. And if you're going to use set builder notation, just remember to throw the y is an all real number such that line, and then put it in these kind of brackets. But yeah, that's going to be everything for number 1. So let's move on to number 2. Number 2, given the parent function f of x equals the absolute value of x, describe the transformations to the new equation f of x equals -x minus 4 plus 3. Okay, so if you're stuck on this, I cannot stress it enough. You need to graph the equations. So let me show you what that's going to look like. So what I've done here is I've graphed the original f of x equals absolute value of x, and then I went left to right with the transformations. I threw in the negative, then I threw in the -4, and then I threw in the +3. So, and it's all color-coded. So let's go through this one by one. So the red's the original, and then the blue is the first transformation. So what is that negative on the outside doing? That negative on the outside is making it reflect, because it was opening up and now it's opening down. So what axis is it reflecting over? Is it reflecting over the y-axis or reflecting over the x-axis? And so if you look, it is folding over that x-axis. So you can just say reflect x-axis to keep it short and sweet. All right, so, and if you want, point to what you're talking about. So the next thing we need to cover is this -4. What's happening there? So the -4, well, from the blue graph, it moved to the green graph. It moved 1, 2, 3, 4 to the right. That's because subtracting anything on the inside of the function makes it go to the right. Remember, adding on the inside makes it go to the left. So you just simply say right 4 units. And then what's the last thing we need to cover? That +3. So what happened with the +3? Well, from green to purple, it went up 1, 2, 3. So anything you add on the outside makes it go up that number. If you subtract it, it's going to go down. So this one, we'll just say up 3. And yeah, that's all there is to say about number 2. So let's move on to number 3. As soon as I fix this number. Sorry, wasting time. Okay, number 3. The graph f of x equals absolute value x minus 4 plus 3 is translated 2 units to the left and 3 units down. So if you're going to go to the left, you need to add 2 to the inside. And then if you are going down, you need to subtract 3 on the outside. So we're going to write g of x, because if you change a transformation, you're not going to use f anymore. You'll just change the letters. So next letter in the alphabet is g. So g of x equals, and we have x minus 4 plus 2. So what's -4 plus 2? That'll be -2. And then what is 3 minus 3? That's 0. So all I need to do is write this down. This is my answer. G of x equals the absolute value of x minus 2. And then if you need to check your work, graph it. So here's the graph of the original, x minus 4 plus 3, and then I graphed my new function, x minus 2. So did it move 2 units to the left? 1, 2, and 3 units down. 1, 2, 3. Yes, it did. So that's all there is to say about number 3. Let's move on to number 4. Find the solutions to 5 minus 3 times the absolute value of 2 plus 2a equals -7. All right? So the first thing you need to do is get rid of everything on the outside of the absolute value. So remember, absolute value cannot equal a negative number, but if you have stuff on the outside, you need to get rid of that first before you can say it's no solution. Because it's real tempting to say, oh, it equals -7, no solution. But let's see what happens when I minus 5. I'm going to get -12. It's still negative, right? But I have -3 on the outside still. So that -3 is multiplying. So I need to divide that out. So if I divide a negative number with another negative number, it turns positive. So now I have the absolute value of 2 plus 2a equals 4. And so once you have it down to the absolute value bars equals something else, make your two equations. So I'm going to say 2 plus 2a equals 4. And then I'll do it again later as 2 plus 2a, and then make one side negative. So I'll just say equals negative 4. So let's solve the one in blue first. I need to minus 2 to the other side. That's a number without an a. So 4 is a number without an a. They need to be on the same side. So this says 2a equals 4 minus 2 is 2. So if I have 2a, I know I can divide that by 2. And I get a equals 1. All right? And then just solve it again. So we minus 2 over, but negative 4 minus 2 is now negative 6. So 2a equals negative 6. So split up a number and a letter by dividing. So a equals negative 3. And so that's how you do it by hand. Again, if you're stuck, go ahead and graph it. Let's take a look at the graph and see and make sure that this side will intersect with negative 7 at 1 and negative 3. So just graph this, the entire original equation on the left side only on line 1, and then graph the right side on line 2, and then get the intersection. And then anytime you graph a letter, anytime the letter's different than x, change it to an x on the graph. So let me show you what I'm talking about. So here I graphed the left side of the equation, but I changed the a to an x. And then the right side of the equation is just negative 7. They intersected at negative 3 and positive 1, which is what I said was our answers. So yeah, easy way to check on the graph. Just graph it. You see it's intersecting, so it's definitely not no solution. And then you just menu analyze graph, get the intersections, and yeah, that's all there is to say about number 4. Let's move on to number 5. Find the negative solution to 1/2 times absolute value of x minus 4 plus 3 equals 10. So I can always start with adding or subtracting first. So I'm going to minus 3 to the other side. It's on the outside of the absolute value bars. I need to get rid of that. If it's on the inside of the absolute value bars, leave it alone, okay? So I have 1/2 times the absolute value of x minus 4 equals 7. So how do I get rid of a fraction? Yes, you can divide a fraction, use parentheses if you do that, or just flip that fraction and multiply. So what is 1 over 2 flipped? That's 2 over 1. So I'm going to multiply 7 times 2 over 1. So that's going to give me the absolute value of x minus 4 equals, and 7 times 2 over 1 is just 14. And so now you can make your two equations because I have the absolute value bars equal a number. So I'm going to say x minus 4 equals 14. And then I'll set it up again with x minus 4 and make one side negative equals negative 14. So let's solve the black one first. All I have to do is plus 4 over, and I get 18. And then I'm going to plus 4 over again in red, but negative 14 plus 4 is negative 10. So x equals negative 10. So those are my two answers. That's all it took to do it, but just make sure you do the outside stuff first, and then go ahead and check the graph. Here I have a graph. Remember, you graph the left side on one line and then the right side on the other line, and they intersect at negative 10. We're just looking at the x values here, and 18. So yeah, that's it. Number 6. Find the solutions to the absolute value of 5x plus 2 equals 6x. So we have it with just absolute value bars equals something, so you can go ahead and set it up. 5x plus 2 equals 6x, and then set it up again, make one side negative, so 5x plus 2 equals negative 6x. All right, so let's get all our x's on one side, so I can minus 5x to the other side, And so this is going to say 2 equals, well, what's 6x minus 5x? That's 1x. So just write x. That was quick. 2 equals x. So let's see here. In red, if I minus 5x over, I'm going to get negative 11x. So this says 2 equals negative 11x, which means I need to divide by negative 11 because it's by the x. You can't add it out. You have to divide. And so 2 over negative 11, I don't think that simplifies, so I'm just going to leave it as that. Now, remember your part about extraneous solutions. If you have absolute value bars on this side and no absolute value bars on the other side, but you got letters on both sides, you may or may not have an extraneous solution. When you plug it back in, the answer should be positive. So what is, or they should equal each other if you want to think of it like that. So what is 5 times 2 plus 2? And then what's the absolute value of that? And then does that equal 6 times 2? So 5 times 2 is 10. 10 plus 2 is 12. So this ends up saying 12 equals 6 times 2 is 12. So that works out. This one, if I plug in the negative 2 over 11, you're going to plug it into the original. So I'm going to go 5 times negative 2 over 11 plus 2. And then does that equal 6? Don't write negative 6. Like I said, plug it into the original. 6 times negative 2 over 11. So when you type in the left side, you're going to get 12 over 11. When you type in the right side, you get negative 12 over 11. Because remember, this side will always be positive because absolute value, whether you plug in a positive or negative number, it's always going to output a positive number. If you don't have the absolute value bars, it can be positive or negative. So if you plug in a negative number, it's obviously going to go negative. So these two are not equal. So you say that this solution, negative 2 over 11, is extraneous. And so that means there's only one solution to this equation, and that is 2. X equals 2. So that's the very long explanation of this. Now, what's the very short one? Well, maybe you've guessed it by now. I'm going to go ahead and I'm going to graph this. And then you'll see that when you graph it, there's only one solution. They only intersect once. So here's the graph. And you see that they intersect just once. You see the lines coming up like this, and then it's going there. It's never going to touch the V ever again. I could zoom out, show you a farther zoomed out image, but it's not really necessary. They only intersect at 2, 12, and so 2 is the x value that we just found right there. So yeah, so with this, now I know what the extraneous solution is. What if I ask you what was the extraneous solution? The graph can't tell you the extraneous solution. Only the algebra can, okay? But the graph can tell you the solution, the non-extraneous one. So yeah, I hope that helped. Let's move on to number 7. Express the solution as an inequality. And so we have 1/3 times the absolute value of x minus 4 is greater than or equal to 12. So like I said before, if you want to get rid of a fraction because it's on the outside, flip it and multiply. That's going to cancel it. So what is 12 times 3 over 1? That's 36. So I have the absolute value of x minus 4 is greater than or equal to 36. So this is what I like to do. Remember, I like to throw negative 36 on one end. You keep the symbol pointing the same way. And then you have x minus 4. And then use that same symbol equals 36. Because you'd have to make 2 inequalities, but you flip the sign on the 36 and then you flip the inequality sign. But if you set it up like this, when you throw it on the back end, that is basically flipping the sign. So let's go ahead and solve this. I'm going to add 4 to each end. So that'll cancel it in the middle. And then I get negative 32 is greater than or equal to x, which is greater than or equal to 40. And remember what I said in the notes. I said that the symbols need to point left in order for it to be written as one inequality or a compound inequality. So I'm going to rewrite this as x is, and see how with the negative 32 it's pointing to the x? So I'm going to say x is less than or equal to negative 32 because it's still eating the 32 but pointing to the x. And then you're going to say or, because if it's pointing opposite ways, it's going to be or pointing to the right if you want in this step. But it'll definitely point opposite ways because when you write it again as x is greater than or equal to 40, you see the symbols are pointing opposite ways. So this would be the answer. So the question said express it as an inequality, so we're done. But just because it's the review and I feel like being really thorough, I'm just going to draw the graph. I have negative 32. That's going to be a solid dot because it's underlined. 40 is a solid dot because that's underlined. And when you have an or inequality, they're going opposite ways. So that's what's going on. You can plug in any number greater than 40 or less than negative 32. But yeah, that's it for number 7. Now, I did graph this one before I move on to number 8. And the graphing, it doesn't really show you that it's shading on the outsides, but it does show you your boundary points of negative 32 and 40. So you can still graph it as an inequality and get the boundary points at the very least. All right, just wanted to point that out. Number 8, express the solution as an inequality again. So I have a 3 in the outside, so I'm going to divide it. What's 60 divided by 3? That is going to be 20. So it's less than 20. So once you have the absolute value bars, greater than or less than a number, make your two-ended equation. So I'm going to write negative 20 on one side, and I'll put negative 2x minus 6, and then I'll put less than 20 on the other. So here I have my two inequalities, my double-ended inequality. So the first thing to do is to add 6 to each end. And so that's going to cancel it in the middle. Negative 20 plus 6 is negative 14, is less than negative 2x, which is less than 26. So I have to divide by negative 2, because anytime a number is by a letter, you have to divide it out. Don't add or subtract it out. It's the most common mistake made in an algebra class. So whenever you divide by a negative, you have to flip the inequality signs. So now I have two inequality signs pointing to the right rather than pointing to the left. So this is going to say 7 is greater than x, which is greater than negative 13. Okay, so since they're pointing to the right now, you have to split it up and write it as an or statement. So x is less than 7, or x is greater than negative 13. And usually you write the smaller one first, so I can actually write it as a compound inequality, because look, negative 13 is less than x, but x is less than 7. So if you have your or statement, this might be confusing to some, but if you have usually it's the smaller one goes here and the bigger one goes there. So if it's the bigger one's here and the smaller one's there, it's probably going to be rewritten like that. It might make more sense to express it as a number line answer, because if you are greater than negative 13, because negative 13 comes before 7 on the number line, right? So I have an open circle on these because the inequality symbol is not underlined. If you're greater than negative 13, you're shading to the right. If I'm less than positive 7, I'm shading to the left. So that ends up shading in the middle. So if it's shading in the middle, then you definitely have a compound inequality like that. Okay? So yeah, I realize that might be kind of confusing, but I hope that made sense. Let me show you the graph. Here I graphed the original, and then I graphed y is less than 60 for that boundary line. Again, it doesn't really help you with which way are the inequality symbols pointing or which way am I shading, but it does tell me that it's in between negative 13 and 7. So you'll at least get those boundary numbers from graphing it. So why am I stressing the graphs? If you're unsure, the answer, or at least some of the answer, like some of the answer meaning if it's an inequality, some of it will be in the graph. But if it's an equal sign, the whole answer is in the graph, okay? So if you're stuck or unsure, check the graph. Let's do number 9. Number 9, determine the domain and range of the given graph. So the domain, how is it moving left and right? It's moving left and right freely. So I would say negative infinity to positive infinity. Or use the all real numbers symbol. Okay? So yeah, if you see the graph on the left and you see it on the right, it's going to be all real numbers, okay? Unless it's like curving some way or another, like a waterfall-like graph. But absolute value graphs always have a domain of all real numbers. Whether they open up or down, whether they're skinny or fat. Always all real numbers for the domain. The range, that one always changes. So the range, this is a maximum point because it's going down. So what is the highest y value? The y value is at -1. Don't say -2, that's an x value. You just look at it moving up and down. So it's at -1 and then it's going down forever. So y is less than or equal to -1. And then you can throw your y such that to do the set builder notation. Or you can say it an interval notation. And in interval notation, since it's going down, it's hitting negative infinity. And then it's going to go to -1 as the maximum point. And so that's all there is to say about number 9. That's it for the review. Good luck on the test, and goodbye.